Okay, the next thing we are going to talk about are equations, okay? And an equation is literally just a relationship where there are two things that are set equal to each other. This is an equation. We're used to thinking about equations with a variable in them. And again, a variable is just when we don't know a number, so we use a letter as a substitute for it. So before we get into equations, let's talk about operations. What are operations? You may want to write this down. Operations are really just what we do with numbers. What we do with numbers. I'm going to abbreviate that. And what do we do with numbers? We add, we subtract, we multiply, we divide, we do some other stuff, but those are the basic things. And so when we have multiple things going on, we have to use the order of operations to know which one of these things to take care of first. And in school, you know that we learned PEMDAS, please excuse my dear Aunt Sally. But here in this class, we use GEMA, G-E-M-A. And I'm going to go through each one and tell you what all is included real quick before we start this. So G in GEMA stands for groupings, and these are a few examples of groupings. I may need to switch pens here so I don't run out of room. One thing that you will see that it's considered as a grouping is parentheses. Obviously, anything in parentheses is going to be a grouping. Here's something else. You may see a fraction, and on the top you have a whole math problem. Okay, specifically here, this 2 plus 4 is considered a grouping that would come first if you were going to solve this. A few other things, you may see a square root symbol, and just a note that is called the radical symbol. And inside that you may see a grouping 2 times 5. That part under the square root symbol would be a grouping as well. Alright, so groupings come first, and once you're finished with all your groupings, you are going to move on to exponents. But not just exponents, but their inverse operation, inverse op. And inverse just means opposite operation. So let's talk about some examples of that. Examples, okay, 2 squared, that's an exponent. But what is the inverse operation of that? Well, the square root of a number is the opposite of a number squared. And then don't forget that we also have the cubed root of a number as well. So once we get through our exponents, the M, this one's pretty easy, stands for multiplication and division. So multiplication and division being inverse operations. But what if you have more than one of those? You need to understand that every single one of those, if one of these separate operations here, you are going to solve left to right if you have more than one in a step. Okay, here's an example. All right, if I have 6 divided by 2 times 3, okay, what operations do I have? I have division and I have multiplication, but in GEMA these are included in the same step, so I'm going to go left to right. 6 divided by 2 equals 3, and 3 times 3 is 9. Alright, always left to right in the same step. And then finally you have addition and its inverse operation, which is subtraction. Again, you're going to solve these left to right if you have more than one. Now this works on equations when you have one step in the equation. But if you have more than one step in the equation, you are going to work GEMA backwards. All right, that means you would start with addition, subtraction, then multiplication, division, so on and so forth. Okay, let's solve a few problems. These are great problems to get on the test because they are simple to solve. Now you're going to have to do this on your scratch paper, which if you take the high set, they're going to give you paper and pencil on the side, and you know that I prefer you are a good secretary and we do things the same way each time to keep it all straight. All right, I'm going to rewrite our problem over here. 1 over 4 times x plus 1 equals 8. Here we have multiplication and addition, so we're going Gemma backwards. All right, the first thing is we're going to subtract 1 from both sides. That's going to cancel out and leave us 1 over 4 times x equals 8 minus 1 is 7. All right, don't get confused because this is a fraction. It is still multiplying with x. So to get rid of that, we're going to divide both sides by exactly what we're trying to get rid of, which is 1 over 4. That cancels and leaves me with x equals, ooh, I don't know that. Well, let me get my best friend over here. 7 divided by fraction 1 over 4 equals, it says the answer is 28. Is 28 one of my options? It is. It is C. All right, let's try number 2. Okay, I'm going to switch to a pencil so I don't get confused here. I have 5x plus y equals 27. I'm going to solve this. Oops. And it tells me that y equals 2. So I'm going to go ahead and substitute that. 5x plus 2 equals 27. Again, I have multiplication and addition. I'm going Gemma backwards. I'm going to handle the addition and subtraction first. I will subtract 2 on both sides. That leaves me with 5x equals 27 minus 2 is 25. Luckily, I can do that one in my head. I'm writing on top of tape now, if you can't see. So then I will divide both sides by 5. Let me scoot over just a little bit. X equals 5. My answer is D. Okay. Number 31. Let me adjust my camera just a little bit. Forgive me. Okay. On the graph of y equals 3x minus 5, what is the x-coordinate of the point that has a y-coordinate of 22? Forget all of this stuff about a graph. It's telling us what y equals. Y equals 22. Okay, so I'm going to rewrite my equation. Y equals 3x minus 5, and I'm going to substitute 22 in here for y. 3x minus 5. One more time, we have multiplication and addition, so we're going to work Gemma backwards. I'm going to add 5 to both sides. That cancels. 22 plus 5 is 27 equals 3x. I'm going to divide both by exactly what I'm trying to get rid of, which is 3. And 27 divided by 3 equals 9. The last time I checked, the answer is B. Okay, 37. Here we go. Let me slide that right up under there so that we can get to it. What is the x-coordinate of the point where y equals 3x minus 9 crosses the y-axis? Okay, so let me draw a little photo here, a little picture. We're going to say that this is our x and our y-axis here, okay? Somewhere, it doesn't matter where our line is, okay? But somewhere here, this thing is going to cross the x-axis. And where it does, our coordinate would be x something, we don't know what it would be, but y is 0 because it doesn't go anywhere. Okay, so we're going to substitute this 0 in for y here. Y equals 3x minus 9. Again, we're going to put 0 in there. Equals 3x minus 9. All right, we have multiplication and addition, so I'll add 9 to both sides there. That cancels. 9 equals 3x. Going to divide by exactly what I'm trying to get rid of. X equals 3. Okay. D, that's our answer. There you are. All right, and then I have one more problem over here. Forgive me just a minute. On this side. I was trying to save paper here. Okay. What is the solution to the system of equations shown below? Okay. We could use a whole entire piece of paper here solving all of this, or I'm going to show you the easiest way, but you have to remember we have 2 equations here that we have to look at, okay? And anytime your answer choices have a number, 2 numbers in parentheses separated by a comma, you have to remember that the first is going to be your value for x, the second is y. This goes in alphabetical order if you get confused. X, Y, Z. Okay, X always comes first. So this is all we're going to do. We're going to take this, we're going to start with A. We're going to substitute 4 in for X and -7 in for 4. All right, we're going to put this in our calculator. So that would be, for number 1, you see my calculator here? Let me get lined up just right. Okay, we're going to say 3 times 4 plus -7 equals, now we're going to make sure this equals 5. It does, but we have to check both equations. All right, 5 times 4 plus 2 times -7 equals 6. Well, lucky for us, the answer is A. Okay, if it wasn't, we would cross off A and move on to B and check it. This way is going to save you a ton of time on the test.